Hello class, we're going to do some exercises here. We're in chapter 2, lesson 5, set 2, number 4. Now, problems number 4, 5, and even 6 kind of all tie together, uh, actually even into 7, and you're going to see a progression. What we're trying to learn here is how each of these constants and how the table in itself uh, reveals information about our graph. So if we really pay close attention to this, it's going to help us further down the road in understanding other concepts that we're going to learn. So let's go to number 4. If a function is linear, it has an equation of the form y is equal to ax plus b, in which a and b are constant numbers. These numbers determine the position of the line that is the graph of the function. Now, we're told to make a table for each of the following linear functions, letting x equal to 0, 1, 2, and 3 in each table. So we're given 3 here, and we're going to go y is equal to x plus 2, and we have y is equal to x plus 4, and we're also given y is equal to x plus 7. Okay, so we see here 3 different formulas, and we're going to create a simple table of each one using the x variables that they've given us of 0, 1, 2, and 3. So we'd write 0, 1, 2, and 3, and 0, 1, 2, and 3, 0, 1, 2, and 3. So if we plug in our values, what are we going to get? Well, we plug in 0 for x, y is going to be equal to 2. 1 for x, that'd be 1 plus 2, that's equal to 3. 2 plus 2 is equal to 4. 3 plus 2 is equal to 5. Let's go down here. 0 plus 4 is equal to 4. 1 plus 4 is equal to 5. 2 plus 4 is equal to 6. 3 plus 4 is equal to 7. Now we have x plus 7, so 0 plus 7 is equal to 7. 1 plus 7 is equal to 8. 2 plus 7 is equal to 9. And 3 plus 7 is equal to 10. Okay, so we now have our table. Now we're told to graph the 3 functions on one pair of axes. Write each equation along the line. So what we're told to do is, when we say one pair of axes, means we just want one axis that we have here to the right. You don't need to draw 3 different graphs. We actually want them together, because when we look at letter E, we're asked to look at the lines, and we're asked what do we notice about the line. So we're going to first off get a black marker instead, and we're going to go ahead and place our points here. Now I'm probably not going to have enough room to do this down to the last one. I see that the y value down here is going to go further, but we'll still be able to get our graph, or at least a portion of it. So I'm going to number these in increments of 1. Okay, actually we could have a 10 up here. And did I do that right? 1, 2, 3, 4, 5, 6, 7. Ah, I don't have a 10. This is an 8. Let's just erase that. And that would really terribly mess up our graph, especially when we get to that area. I didn't think I had 10. I don't know why I had 10 there, but I missed the 8. So this is 0 again. And, this is 0 for here, 0 for there. We can say the O of the origin. Okay, now it looks like a bear track almost. But we have here 1, 2, 3, 4, 5, and we can go on. I'm just going to stop there because we're only really going to go out to 3. So what do we have? Well, the first graph would be of y equals x plus 1. So we go to 0. We have 0, 2 as our first point. So we start at 0 and we go straight up. Okay, so that's our first point. Our next point is 1, 3, so we go over 1 and up to 3. And then we have 2, 4. And I'm already spotting, again, the pattern here, 3, 5. Okay, now we have 0, 4, so we start at 0. And since we don't move over, we stay on the y-axis, and we put our point at 4. Then we have 1, so we move over 1 to 5. Then we have 2. We're going to move over 2 up to 6. And the last one is 3, 7. Okay. And then our last formula, we have y is equal to x plus 7. So we move 0 and go all the way up to 7. We start there. Put our point. Then we have 1, 8. We have 2, 9. And if we did have that 10, it would be somewhere out here. Let's just put it on the edge of our board as 3, 10. Okay. Now we should graph these. So let's go ahead and draw the line. And connecting these dots across, we have our first graph, and we can extend this all the way out. Okay. Here's our next one. And our last one. So, what do we notice about these? Well, they're all lines, sure, but we already knew we were going to have lines. The question is, well, what could we say that we see in comparison to the 3? Well, we could see that they're actually parallel, okay? Which means the distance between each point is the same all the way across from one line to the next. So we can say that they are parallel. Now, where does each line meet the y-axis? So each line, where does it meet? So the first line, we see that it meets here at 2, okay? So we'd write down that 2 would be the first one, 4 would be the second, and 7 would be the third. And again, let's take a look over here. Let's get my where do we see these numbers? Well, we see it right here. There's 2 over here. There's a 4, and I actually would include the positive, okay? Later on, we're going to go into negative numbers, but that positive 4 would be the spot there, and positive 7. So we had that positive 2 over here. Let's just put a circle around it. So we see that in our equation. We see the y point showing up in our equation. Okay. Now, where do you think the graph of y is equal to x plus 10? So if we wrote down y is equal to x plus 10, and it says, where do you think the graph of the equation y equals x plus 10 would meet the y-axis? Well, we know. We've already spotted that. It's right there, the 10. So if we were all the way up here somewhere, that would meet right here. It would start right around there, and again, it would look just like these. It would be parallel. It would run across. We're not asked to graph it, but we know it would start at that particular point. And that's good to know, the starting point of the y-axis. Again, we're building our knowledge base here, so we're going to need that further along as we learn the shortcuts.